Hi everyone, in this video we are going to explore some advanced function features in TypeScript including arrow functions, generics, and higher order functions. Arrow functions are a shorthand way of writing functions in JavaScript, and you may already be familiar with them, but in TypeScript they become even more useful, especially because of how they handle the this keyword. Now, those of you who watched my JavaScript crash course will remember how this behaved differently in regular versus arrow functions as we discussed this a lot. But for the rest of you, and including yourself, let me give you a quick recap because while this isn't a TypeScript specific feature, it becomes more important when working with TypeScript. In regular functions, this refers to the object that call the function. Arrow functions, on the other hand, do something different. They lexically bind this, which in English means they capture it from the surrounding context. So let me type an example and that would be clear then. Okay, let me get this out of the way. I meant the terminal, not this. Okay, so in the first example, we are using a regular function inside set timeout. Here, this is no longer pointing to the person object. Instead, it is pointing to something else entirely. And TypeScript doesn't know what this is supposed to be. In fact, it gives us this warning. This implicitly has type any because it does not have a type annotation. This happens because in TypeScript, we are expected to be explicit about types, even for this. And fixing this in a regular function is not beginner friendly at all, so I wouldn't even attempt that. So why is this happening? I can quickly tell you that while greet function belongs to the normal person object, the set timeout callback function does not belong to that object. It belongs to something called global execution context, which calls it once the 1000 millisecond timeout occurs. Using this keyword in that callback means it does not point to the object, and if logged to console, we find out that it is undefined. While knowing that using that keyword is useless at runtime, TypeScript adds another level of complexity that it requires you to specify the type of this at compile time. At this stage of learning, it suffices to say that there is no easy way out except one, using arrow functions. See, arrow functions handle this differently. I already used the term lexically bound before, which means they can infer this from the context in which they are operating. In the second example, this indeed points to arrow person object, and we don't get any complaint from TypeScript either when we use this keyword in our second example. All it takes is removal of function keyword and putting an arrow before the function body. What more can you wish for? So even though arrow functions might just seem like a shortcut, in TypeScript they actually help you avoid confusing bugs and frustrating type errors related to this. And that's why we are covering them here. Arrow functions also allow us to write shorter, more concise functions, especially for one-liner functions. Instead of using the full function keyword, we can use a more compact syntax. Let me show you a simple example of how you can write a one-liner function using arrow functions. This is much shorter than a traditional function declaration, but it does exactly the same thing. The arrow function is ideal when you want to keep your code compact and easy to read. I can quickly demonstrate using a console log. So now if I do this, you can see 8 being written through the screen. All right, this brings us to the end of the functions part. In this part, we explored arrow functions and how they handle this lexically, as well as how they allow us to write concise one-line functions. Arrow functions are great for reducing boilerplate code while ensuring that this behaves in a predictable way. Let's move on to another powerful feature in TypeScript called generics. Generics allow you to write code that works with any type, while still keeping the benefits of type safety. Think of generics like fill in the blank type. You don't log in a specific type, instead, you write a function that can work with whatever type the caller provides. Making any sense? Of course not. So let me type an example and then it would. Alright, so in this particular example, t is a placeholder or a type variable. When we call the function, TypeScript figures out what t should be based on the value we pass in. Right, so as you can see, T became number in the first call and string in the second. You didn't have to write different functions for each. That's the power of generics. Most of the time, TypeScript can figure out the type for you, but sometimes it can't. In those cases, you can tell it explicitly using angle brackets. Alright, let's say you want to parse a JSON string here and treat the result as a specific type. You can pass that type in manually like this. Alright, we expect the output to be Alice. Let's see. And here we go. Alice got printed to the console. So what happened here? Here we explicitly told TypeScript the result of parsed JSON should be treated as a type user, which we defined right here using the type keyword. This gives you proper IntelliSense, type checking, and error detection. Super helpful. And this pattern becomes especially useful when you are working with the Fetch API and getting data from a server. Since Fetch gives you a raw JSON, using generics like this help you safely work with the expected shape of the data. In fact, I think I won't be doing any justice if I just use this dummy data example and ignore this super important and practical use case. So let's take one step further and go ahead with a real world use case because you would definitely be using this example that I'm about to show you. So JSON placeholder is a website that gives you dummy JSON objects when invoked using its API. So that makes it an invaluable asset when trying to show you a real world example using type fetch. So by passing post type to this fetch post function, we are saying I expect this API response to match the post structure. And this is a post structure, ID, title, and body. And because of that, boom, full IntelliSense, type safety, and helpful tooling. You notice that as I typed fetch post dot title, I got this complete IntelliSense. And even when I hovered over this then, you can see the callback function had this value post being written out. This is how to get everything working smoothly in the typed world of TypeScript. And this brings us to the end of the generics section. In this section, we figured out that generics let you write flexible, reusable, and type-safe code. You can manually specify the type when TypeScript can't infer it, like with JSON parsing, and you can constrain generics using extents to require certain properties. It's the best of both worlds, flexibility and safety. Now let's dive into higher order functions. Higher order functions are functions that either take other functions as arguments or return functions. These are powerful concepts in functional programming and can make our code more abstract and flexible. By using higher order functions, you can pass behavior to functions, making them more versatile and reusable. Let's look at an example where a function returns another function. Need an aspirin? All right, hopefully not to explain this. So in this example, we have a function called create multiplier that takes a factor and returns a new function. The return function multiplies its input by the factor we passed when we called create multiplier. Let me show you how this works in practice and hopefully it will make sense. We can create a multiplier function for any factor and then use it to multiply number. Is it starting to make sense now? As you can see, we created two different multiplier functions, one that multiplies by 2 and another that multiplies by 3. By calling create multiplier with different factors, we create new specialized functions. This is a great example of how higher order functions can be used to generate custom behavior dynamically based on the parameters provided. If it's still not making much sense, note this is a type, which is representing a function which takes a number parameter and returns a number. So here we are creating that function and returning it as a return value of create multiplier. So when you call it with 2, we return a function which takes an n parameter and its body comprised of multiplying n by factor, which was 2. I can only hope that it made sense, but if it did and you are able to use it in practice, it would be an invaluable lesson that you will learn today. So we can move on and look at a higher order function that accepts another function as an argument. This is another form of higher order function and is commonly used in many programming scenarios. So in this case, we'll define a function that takes an array and a callback function. The callback will be executed for each element in the array. You're already familiar with how callback functions work, so hopefully that should be a bit simpler. So let me type the example. So here, process array takes an array of numbers and a callback function. It then runs the callback function for each element in the array. Let's see how this works in action. So we'll pass a function to process array that multiplies each number in the array by 2. As you can see, process array accepts the callback and calls it for every element in the array, allowing us to perform a custom operation on each element. This is a very common pattern, especially when dealing with operations like filtering, mapping, or reducing data. So in this mind-bending section, we covered higher order functions. These are functions that either return other functions or accept functions as arguments. We saw how higher order functions can make our code more flexible and reusable by allowing us to pass behavior around. So to wrap up the entire section of functions, we have covered several key features of functions in TypeScript. Let's quickly review what we have learned. Function signatures, we learned how to define the parameters and return types of functions to make them type safe. We saw how to make parameters optional or set default values to make our functions more flexible. We explored how to define multiple function signatures for the same function to handle different types or numbers of arguments. In arrow functions, we discussed how arrow functions are concise and how they handle this lexically. We also just saw how to pass arrow functions as arguments to another functions or return arrow functions as return value from higher order functions. In generic section, we learned how to use generics to write flexible functions that can handle different type of data. And in higher order functions, we explored how functions can accept other functions or return functions, allowing us to create more abstract and reusable code. These concepts are some of the building blocks for writing powerful and flexible code in TypeScript. I encourage you to practice using these features in your own projects to become more comfortable with them. The more you practice, the more confident you will become in writing type-safe and maintainable code. In the next section, we'll talk about object-oriented programming with TypeScript. Stay tuned.